They've got a really great speaker lineup, so check it out. Other than that, we've got Reed today. Reed's coming at us and going to talk to us about, programming languages where they shouldn't go, right? Yeah. Before we jump in his talk, though, let's give a shout out to all of our lovely sponsors here who make this pizza that you're eating possible and in this space. So, yeah. Anyway, without further ado, everybody give it up for Reed.
Test. Microphone. That sounds good. Yeah. Sounds like my conscience. I will talk louder. All right. My name, how do we get this going? Thank you. Yeah. My name is Reed Spool. I do independent software stuff. Oh, I forgot about this. I should have changed my slides because you guys on the side, you can't see the lower left corner. That's where all the funny bits are. So let's just get this out of the way. I do independent software stuff. That's my Twitter handle and my GitHub. I'll post these slides in the meetup group in case any of you are not totally bored. Here's what we're talking about today. Big fish in a little pond. I have like 4 names for this talk that I think are really clever and funny. Or a Turing-complete language rudely appended onto a URL. Or, as I put it in the meetup, what do we call it? Thank you. What do we call it? Programming languages where they don't belong. Here's a little bit about what I'm planning to talk about, but we can go off course. We're going to break down what a URL is, in case you've never thought about the different components. Should we mess with the URL? I think so. What kind of language could we put in there? What do I mean by concatenative? What is factor? And finally, my project, the URL programming language. All right, before I start, I'm going to leave it on this slide for a second. Before I start, who here knows at least one programming language? Writes in it, does their homework. Was everyone really excited when you first learned a programming language and you could do all the math homework you ever did in school? And you were like, yes, but you were already too late. It's really disappointing. All right, who knows about functional programming languages? Functional programming languages. All right, keep your hand up if you use a functional programming language regularly. All right, a little less. We got some iffies. That's cool. And then finally, who has heard of concatenative languages? We've got a few. All right, cool stuff. So concatenative is a different paradigm than functional. We're going to get there. I was just interested to know about y'all. All right, so what's a URL? A URL is a location and a mechanism for retrieval of something. What's something? Well, it's a uniform resource locator, so we're going to call the something a resource. What is a resource? I don't know. It's pretty up in the air. Usually, it's a document, like a web page. Sometimes it's a PDF. Sometimes a music file. There are all sorts of things. Sometimes it's like the Twitter homepage. It's this amorphous blob of information that's constantly changing. If you try to get that resource twice, you're going to get different information. Interesting. All right. What's in a URL? What are the different parts? This is the most boring look at a URL ever. Pay attention, though. There will be a quiz next block. We have a schema name, colon, 2 slashes, then a host. Then there's a colon, then a port number, maybe. Then there's a path. Then there's a query string, optionally, and a fragment identifier. So down here, I have an example of a real site that is probably not porn. So we have Here's the schema name, HTTP. That's the protocol that we're going to use to get this resource. Then a colon and 2 slashes. Who decided on that? I don't know. It's the least fun to type. Then this whole thing right here is the host up to that slash right here. Then images.html. That's the path. Then we have a question mark. That sets off the optional query string. And finally, a hash mark at the end sets off the optional fragment identifier. That one's got everything. Good stuff. Here's a more visual broken down look. I don't know where I got this image, so I'm going to brush past that because I don't feel good about using that without a reference. OK, so what are all those parts used for? The World Wide Web relies on the schema name, the colon, 2 slashes, and the host. That's all the World Wide Web cares about as far as HTTP and the actual standards that are in books, in white papers, and such. And in your routers and in the DNS. So that's this part, up to that 3rd slash. Only the browser cares about the fragment identifier, so that part at the end. The server will probably never see that unless you do some weird stuff. And this is the important part for me. What happens between the 3rd slash, that one, and the hash mark is entirely in the server's hands. Wahahaha. I keep forgetting I have this thing. Yes. So this experiment that I've done, rudely appending a language onto a URL, is a back-end experiment. It's an experiment with servers. So I want to play with what's in the server's hands. Oh, and now a huge block of text. I'm sorry I showed you that without warning. That was scary. I want to talk about REST. Who here is familiar with the term REST? You might have heard it as RESTful APIs. You should go home and get a REST. So in 1994 to 2000, this guy, Roy Thomas Fielding, who is the RTF in RTFM, that's a bad joke. He wrote this. He wrote his doctoral dissertation on the internet, on how servers should act on the internet. And there was a big section that he called REST, which stands for Representational State Transfer, which is totally. I hope that's not me. That would be awkward. OK, and I'm just going to read some selections from this about REST because he is the reason that we have the internet that we have in large part. There was a lot of other people, but he wrote a really awesome, really long and dense dissertation on REST. OK, so it was the first edition was developed in 1994 for along with HTTP. So HTTP is the underlying transfer mechanism for this stuff. REST is just an idea on top of HTTP, but it was built along with it. At first, they called it the HTTP object model, but that didn't sound right. So they changed it to representational state transfer to evoke an image of how a well-designed web application behaves. A network of web pages where the user progresses through the application by selecting links, resulting in the next page being transferred to the user and rendered for their use. So this is a description of the web as most of us use it, and it appears to us. It is not, however, intended to capture all possible uses of the web protocol standards. We're going to have a different use for it in just a second. The important point is that REST does capture all of the aspects that are considered central to the behavior and performance requirements of the web. Boring. REST is optimized for the common case so that the constraints it applies to will be optimized for the common case. We're not the common case today. But that is to say, the reason I put this up here is because to make that point, that what I'm talking about is not a better way. It's just an idea, and we should probably still be doing this stuff like in the future. All right, one more huge block of text, and I promise there's no more. It is the nature of every engineer to define things in terms of the characteristics of the components that will be used to compose the finished product. The web doesn't work that way. You shouldn't be an engineer when you're working on the web, is what he's saying. Don't think like that. Just go architecture. Just use the constraints of the communication model between components. Blah, blah, blah. OK, too much text. I really just like his line here. The web doesn't work that way. Because what I'm about to talk about as far as the URL programming language is some characteristics of components that we will compose the finished product out of. So this guy, Roy, is telling me, don't do this. This is really dumb. All right. So why do I think it's worthwhile to explore? The current standards are restrictive. So RTF was literally applying restrictions. He's saying, don't do the crazier engineering stuff. Make it as simple as possible so that it works really fast, really well. Here's another point. Loading a rich web page to use their tool to retrieve a resource can be ridiculous. So for example, if you want to search on Google for Google Images for, let's say, 400 by 600 animated GIFs of cats, you can do that, but it's a lot of clicking. Okay? Why not instead give some composable tools that you can say, you can put those numbers in instead of clicking Google Images, advanced search, and then going through a form. Why not use a programming language? The address bar is the most universal input box. I got this stat from a Pew Research report this year. 54% of adults in emerging economies are internet users. That's what they call themselves. They identify as internet users, which means they've all touched an address bar. That's a lot of people. And that's a lot of people that maybe we didn't consider as internet users before. So a lot of people have messed and at least seen typed into this address bar. All right, why shouldn't we do this? I should have changed this slide. It says why not, and then it has a pro and a con thing. I still don't understand what I'm going for here. So, OK, so nowadays with software as a service, like I mentioned, Twitter, your Facebook feed, resources on the internet are no longer just static pages. There's a lot of stuff going on when you go to facebook.com. There's a lot of code that gets run. And hiding all of that is really useful to end users, but why not make some composable tools? And Rails, Node, Django, not so much WordPress, not so much Apache, but we have tools now to make really interesting things out of servers. So best practices ease a lot of headaches. So what I'm about to show to you is probably a resource management and security nightmare. I hope that I express enough to you about it that you can tell me why. I would love to have that conversation. I don't know why I keep working on it, because it's obviously like a terrible, terrible idea in terms of those two things. So let's have that conversation. You can knock me out of it. OK, so this is one of the huge fallouts from, if you've ever read something on RESTful APIs, they talk about this all the time. So hey, if we make our URLs really nice, then people will be able to remember them and just like type in stuff. I've never seen a user do that, ever. I've done it myself, but this is my job. So like I hope that I can figure some of that stuff out. Real people do not remember long URLs, even if they are set up nicely. So that's another great antithesis to my little project. Whatever. He's moonwalking. All right. All right, so whatever. What should we do? How should we go about this, plugging a programming language onto a URL? Here's an idea. Hey, look, like I can just type in Ruby, print and then a string. So this gives me a lot of control. Now I can change that text. I can put my name in there, hello read, right? I have more control over the output. I don't know what that produces. Maybe this produces a web page that just says hello read. I don't know. But that's more control than our standard www.google.com/something something. This looks like a really bad idea, though. Here's more Ruby code where I define a function for later use, a composable, component. But I have to use new lines. Nobody likes new lines in their URLs. So we're going to have to deal with that. This looks way worse. I still don't know. This is going to be on your quiz next block, what this code actually does. But here's some Lisp. And what I really don't like about this is that you have syntax on both sides of what you're trying to write. So like if you want to change something in here, if you want to add another list in here, you might end up having to go back and put a parentheses later. All right, so C-like syntax is bad, Lisp is all right, but there's a lot of parentheses. So enter concatenative programming languages. Learning about these things is what made me interested in working on this project. Is how I thought of it was, let's just tack stuff on. So I'm gonna show you how we just tack stuff on with concatenative programming languages. So here's a small program. Can we guess what it does? 12, yeah. Okay, so this is 3. I'm going to go more in depth as to how this works in a moment. But first, we have 3, then we have 4, then we have times. So times is acting on what was already there, the 3 and the 4. All right, going further, 3, 4 times 2, 3 plus times. All right, that's looking crazy, especially if you're familiar with other types of programming languages. You probably are just shocked at 2 operators next to each other. All right, I'm gonna back out of my little presentation here and go into not my project, but a well-formed sort of concatenative language. Is this working out? All right, let's get the aspect ratio here, and then. Yeah, sweet. All right. Cool. So this is a programming language called Factor. I just found it with my explorations of programming languages, concatenative languages. It's really nicely built. They have tons and tons of tools and functions, but I'm just going to show you the basics. So the basic idea is that we have a stack. You can't see it yet, but let me put something on it. Put a 2 there. Everybody see the 2? Cool. All right, so I hit enter, and we get the result is a data stack with the number 2 on it. Oh, it's real close to the side there. Let me bring it off. Oh, no. I did that. Did I just break our projector? Woo! A lot of wires over here. I'm going to push this a little out so I don't do that again. All right. So we got a 2 on the data stack. I'm going to put a 3 on there. Cool. We got a 2 and a 3. The order is, of course, important. Now I'm going to do an operation called a plus. Boom, 5. So a very specific order of things happened. First, we pushed 2 on the stack. Then we pushed 3 on the stack. Then plus took 2 things off the stack because plus is a binary operator. So it went pop, pop. It did its plus thing. And then it pushed the result back onto the stack. And we get a 5 back on the stack. Here, I'll try to plus again. Oh no, data stack underflow. I don't know what that means, probably bad. Let's put something else on the stack. Let's do a times. Okay. So notice that unlike maybe other interpreters you've used, I didn't have to write an entire program to get it to execute on the line. I just wrote a single operator. I think that's really key for why I thought this was a cool thing. So let me clear it. And so 2, 3 plus is the same thing as 2, 3 plus. Maybe that doesn't seem like such a big deal, but then that allows supreme amount of composition. So if you already have stuff on the stack, I can come along and plus it. Or I can write a program that has all that stuff already in it. All right, so back to, I had an example over here. What do we have? Boop. 3, 4 times 2, 3 plus times. 3, 4 times 2, 3 plus times, just for round it out. We get a 60. Cool. Let's see some other features about concatenative languages. So first of all, 3 times is also valid syntax. Oh, that's too far down. Let's clear it. Bump it up. Cool. 3 times is a program. It's a composition of 2 functions. 3 is a function that pushes 3 onto the stack. Times is a function which takes 2 things off the stack and pushes back their product. So 3 times is also a program. We can write functions like that. So if I push this onto the stack by hitting enter, we see that that's now one thing. And that's a legal thing. It's called a quotation. It's a quotation. I think I'm funny, guys. I'm going to call that quotation. It's a callable. And what that does is exactly what it would have done if I had just written it. So we get the result of 63 times. Sweet. Let's clear everything off. I'm going to show you some more stuff. So if you've seen functional programming before, you can also do fun functional stuff. So of course, a list of numbers is also a legal program. So we can push that on the stack. We can now just do something to it 10 times. So let's say, or not 10 times. How many numbers do we have there? We have 8 numbers, so 7 times, let's just add it. Oh, that didn't work. We need to call that. Push all those onto the stack. Then 7 times, we'll just add them all together. That looks a heck of a lot like, don't do that. That looks a heck of a lot like reducing. Same result. Do they equal each other? Oh no, you're too far down. I don't know what equal sign does. All right, so maybe I should have noted, I'm not a proficient at this language. I don't use it for work. I just think it's really cool. All right, back to a Prezi. Oh, cool. All right. Concatenative programming is so called because it uses function composition instead of function application. So normally, with you guys who are familiar with functional programming, if I say f of g, that means I'm calling the function f with the function g as a parameter. In concatenative programming, when you put those two together, you're just you're literally composing them by putting them next to each other. So 3 times is a composition of 2 functions. Here's another big block of text. I'll skip over that. All right, so there's factor. I'm not that good at it. It's stack-based. There are concatenative languages that aren't stack-based, but they act like they are stack-based. The steps are very simple to execute them. First, the functions are composed. Then the result is applied to whatever's on the stack. The stack gets shifted when that application happens. Then whatever's left on the stack is your answer. So let's bring this little guy to the interpreter. That's what we did before. I went out of order. I'm sorry, guys. All right, so before we go to my little experiment, here's what I think about the internet. I think users should be empowered, so let's give them some composable tools, even if Roy doesn't want us to. Let's provide an interpreter as a service. I think concatenative languages have all the right properties, and whatever's left on the stack, the user gets back. So let's go to the web with those thoughts in mind. All right, so, man, it's so hard to see the URL bar. I should consider that. Here we go, I'm gonna zoom in. So y'all can see what happens. So here's my little Heroku app. It's at concatenative, spelled wrong, .herokuapp.com/execute. And then here's a little program. The spaces get replaced by %20s when you hit enter. And here's the result. So as I said, this is a server experiment. So the front end is the most ugly front end that I've ever personally produced in my life. So sorry, but here is the result of that program getting run. So here is the input as a program, and here's the output. So I modeled my language off of Factor. It uses a lot of the same properties. I'm not as good at writing languages as they are, so it doesn't work so good, but this is real simple. This concatenated, no pun intended, hello and world. So that's a simple program, and we shoved it all right in the URL bar. So here's why I think concatenative languages are the right thing, because I can just go ahead and add more stuff and do even more stuff. Real simple, just by adding to the end of the URL. You definitely can't do that with Google. All right, let me show you some fun use cases. So it's cool to make a language that is on the internet because you can make its domain the internet, meaning that hello world is a pretty boring example unless you're on a text interface. So why not, let's make our hello world like a GIF. Everybody loves GIFs. So this is just my convenient input here. I hit enter, and that gets translated up there. I'm going to scroll back up here. Hello. I'm so glad that's not inappropriate. It's always a risk. All right, so hello was pushed onto the stack. We can break that down. If we just type hello there, the entire result is hello. It's a link right there because it just does the exact same thing. If I click on it, it does the same thing. You can send that link to somebody else if you want to say hello to them in the most roundabout way possible. Then the function GIF pops one thing off the stack, goes to Giphy, and searches for a GIF. Hello. Wow, we're killing it today with the GIFs. All right, so let's go a little further. Let's find, let's see, I'm gonna type in happy, sad, crazy. And so that I put that in a list in those square brackets, and I'm gonna pick a random one of those. Okay, so the result was happy. If I refresh, we'll get a different one, maybe. All right, we got sad twice. It's a sad day when that happens. All right, I'm going to duplicate it. So now we get two sads. And then I'm going to find a GIF for it. Same way as before. OK, cool. So now we've just built, out of composable tools, a random GIF generator with a known input. So now we know it's not just like Giphy's completely random generator. We have known seeds there, so that's cool. What if we wanted to do that, I don't know, a bunch of times? Well, we can put all that in a list, a quotation. Okay, so it doesn't get run. The only thing that gets run is the quotation itself gets pushed onto the stack. And now let's do that 10 times. Let me. Okay, cool. So we got a little crazy, a little sad, a little sad. Nothing inappropriate yet. We love that. All right. Cool. Let's think about a different use case. Well, I'll back up for a second. So I made this front end as terrible looking as possible, but you can very easily imagine that the things that get returned here could be put in a basic HTML layout with a nice style, maybe some Bootstrap going on. Everybody loves Bootstrap. So very quickly, we could be making something that looks nice. That was not my goal. I wanted to scare you guys. Let's go into a different use case here. What if I wanted to, I don't know, let's see, give you a link to do almost the exact same thing. So, but for any word you want. So I'm going to make a form. Input, all right. So here's my form syntax here. Over here, we're going to do a word. So that's going to be, well, let's just see what happens there. All right, so we got a form, an actual HTML form. And if you guys can see, it has a placeholder text word. When I run it, it won't do anything. That's where this first quotation in that syntax comes in. That's what we're going to do with the word. So let's extract it first, and then get a GIF for it. Oh, let's duplicate it too, so we can remember. Because the GIF function is going to pop the word off the stack. And so we'll duplicate it so that we can see what, and make sure that we wrote the right thing. So let's try, should I type in inappropriate? No. I don't know, JavaScript? They have good ones for that? Okay. Okay, so we duplicated the word, and yeah, cool. So let's just back up here and think about this for a second. This URL, the URL we're looking at up here, complex though it may be, I could send this to somebody. I could text this to one of you in the room, and then you would be presented with this form. You could see what's going to happen when you run that form, or when you run it, but you didn't have to write that. So I made something for you out of these composable pieces. And I don't know, let's try again. Cool. Let's take this one step further as far as use cases go. Let's say that you just had paid some monies to somebody. Oh, let me get that up there. You just paid some monies to somebody, and you're not sure how much the tip should be. All right, so that's going to give us a form with a total and a tip input. Let's do some trippy concatenative programming to calculate the tip. So first we take the total out of the response. Then we multiply it by the tip. Oh, wait, we have to take the tip out too. Really hoping this doesn't get inappropriate. Tip, take that out. Wait a minute. So the tip, when I extract something from an object, that object gets thrown away. So I'm going to need to duplicate it first. Okay, and now, so let's try that. Let's see what happens. Okay, we've got our total and our tip form. So we'll write 17 and 23. All right, so we have on the stack here, we have a form data object, so that's the result, and a 23. Now I'm going to swap those two so that we get the form data object back on top, and then I'm going to take out the total from the form data. Now I can multiply them together. Actually, why don't we add 1? No, we'll multiply them together. Okay, so here's the trap with concatenative programming, is that there's no variables. So you have to maintain your stack very nicely and shuffle it around to get everything where you want. So instead, I'm going to switch these two. I'm going to take the tip out second. This will be easier. I'm going to add 1 to the tip amount, and then we'll multiply the two together, and that should get us a result. Let's make this form. We made a form. We'll say we had 18, and the tip amount was 0.25. We were happy with our service. And there we go, a result. So once again, I could send this form, this link up here, to you, and now you have a tip calculator by going to this web page. And that's not something I thought of when I made this. That's just something I composed out of reusable parts. So I hope that I've expressed to you enough random information by now that you can tell me why this is a terrible idea. And I think we have plenty of time for questions, I hope. But that's it. That's it for the Prezi. Thank you. Any questions? I've stunned you all. Hold on, he's going to give you that microphone. So this is being recorded, so just, I can also repeat it for you, I'm sorry. I'll repeat it.
Okay. What's the limit to the URL? Is it 64K?
The length?
The length
Okay,
of
so
characters.
that's a great question. I did a bunch of research on that. The actual length limit to the URL is pretty much non-existent. It was, in IE, it was like 2,000 characters back in the day, and then they lifted that, and now it's probably in the 2 to 3 bytes range. So the reason that factor is called factor is because you can take out any piece of that and factor it into another reusable component. You can define your own word. And so that when I was thinking about this, I was like, okay, we're going to, with any complex program, you're going to reach any limit you get really, really fast for the length of the URL. Factor provides a really nice way to extract huge chunks of that and define it elsewhere. So you could save it on the server as an alias or a word, and then use that word in your code. So you're not rewriting huge amounts. But yeah, that's a great call. Great question. Yeah.
Can you compose the URLs in the URL? So instead of defining it on the server, define the alias as a URL to another program.
Yeah. So actually, I think I need to stop this for my sanity. So defining an alias is a call on a URL. So you can define it earlier on in the chain and then use it later. Does that answer your question, though? Yeah, as far as, there's no real good use to composing entire programs on top of each other because you still have to use, and I say no good use, I mean no stylistic use, because you still have to use the whole chunk at the beginning, like HTTP, : / all that. Right, yes, Bitly is beautiful and I think is the future. Bitly's the future. If you take nothing else away, Bitly's the future. Yeah.
So you're using the URL bar as the input for your REPL. Just curious, what was the motivation for this project?
Wow, yeah. College? I don't know. No, I don't. I think I found the concatenative paradigm, and I was thinking already a lot about REST. I work a lot on the internet, and just appending things. They seem to go really well together. That in REST you are supposed to append things to the path to get more specific about the resource you want, right? You want google.com/images/ dimensions / GIF or something in some REST universe. And with this, you're taking data that's on the stack and appending things together in order to use that data in a more specific way. Somehow, one late night at 3 a.m., I had this crazy idea, and yeah. As far as motivation goes, again, I am motivated until someone tells me this is a bad idea. Like, I can't get it out of my head, basically, at this point. So please, I won't be offended if you're like, yeah, that's stupid. Yeah.
I've written a lot of JavaScript in the past, and some of it was public, some was secure, and this would be a fantastic idea to eliminate a lot of the load times, because you wouldn't have to wait for it to load before you could use it, and you'd be using very specifically. So in that sense, if there was an interpreter into the browser, I think that'd be an advantage. This still has to hit the server, right?
Yeah, so all the code being run is being run on a server. There's no front-end JavaScript except that takes this and appends it to the URL when I hit enter. So all of the stuff is being run on the server. So the use case I used to give most often was reducing round trips back and forth, right? So for the Giphy example, if you wanted to do that with Giphy, you'd have to go to www.giphy.com. Giphy is just a GIF search engine, by the way. And they have a big search bar like Google. And you'd have to type in happy, and then hit enter. And then you'd have to copy all those. And then you'd have to type in sad, hit enter, copy all those. Crazy, copy all those. And then you could have a list with all three of them together. And that's a lot of round trips back and forth. So I think there is some use definitely to that. Did you also have a question about security in there?
No, I just wouldn't put anything secure in there because you obviously can see it. But I thought that if there was a separation between the two, I think it's a very powerful idea. And yeah.
Me too. You're not helping me out. So get me off of this. Yeah.
So is it multi-user? So is there only one stack on the server? So if we're both hitting it, am I picking up parts of your stack?
Yes. Okay. So the stack, it's actually stateless. So the stack doesn't exist on the server. Yeah. The stack is ephemeral.
It comes into existence for one URL, and at the end of the URL, it winks back out of existence. So if we're both very independent.
Yeah. So it's not like the factor interpreter where it's saving what's on the stack. The resultant stack is sent back to me and shown on the web browser and disposed of.
So that takes care of the security problem.
Some of them. Yeah, there's more. There's more in there. Yeah. Yeah, in the back.
Bear with me on this one. I'm just trying to think how to expand this to the next level, go beyond a little bit more stateless. But for each time you post, the command that you give is somewhat, it can be duplicated. Therefore, it can be stored. Therefore, you can give it an ID. So each time you type a command, however long it is, your server could then store it, generate, I don't know how far you want to go with it, some kind of ID. You turn that back. Now you've just stored a function.
Right.
In the smallest form possible, like as a pointer.
A virtual machine.
Reuse that.
Yeah.
And it's like kind of caching your functions.
Yeah, absolutely.
And then you could go wherever your mind takes you with that one.
Yeah, absolutely. Expanding that out, I definitely appreciate that line of thought. if we can get the server to remember things that it's done recently and not have to rerun that code, that will definitely save a lot of time. I think, and then giving you back a pointer to it. Yeah, so that's
The
so
pointer would be machine readable.
right. So I've personally kept my use cases to showing the user stuff that's totally useful for me to look at. But you saw the form data object in there. That's not useful. You have to unpack it for that to be useful. Go here and then here. Oh yeah, we got here first.
I think like building on that, maybe just use it for memoization, like store a hash of the function that you've defined,
Yeah,
and the result of it. And if somebody runs that again, then spit that back, and then that would alleviate like this vulnerability of denial of service attacks where people are trying to run this a million times. And that
Yeah.
kind of thing. Maybe.
No, it's vulnerable. I admit. I think memoizing is a great idea. I am not going to optimize it until I find real use cases. Is how I feel. But it's a great idea. Yeah.
Can I store any arbitrary string and inject that into the browser?
Oh, I hear you using the word inject.
So like script tag?
Yeah. Please try. Please try. Like I said, this is parsed as a language.
Okay.
So there shouldn't be any unsanitized input anywhere. Absolutely, though, if I am talking about making composable web objects that then get sent back to a user, well, I mean, you could send my grandma a link that showed her anything, or put any script tag in there for,
But like
for your
in
pleasure.
your hello world example, like those are just strings
Right.
that then get like dropped into that input. Like,
Yeah, I mean, we can
example.
try it.
So you could like concatenate script tag alert hello.
Or meow.
Yeah, oh yeah, sure. Cool. Good to know.
Yeah. So hopefully. That is cross-site scripting, yeah. Because here, we'll show you how it can be cross-site. So, yeah, that's funny. Absolutely, that's a vulnerability. So I can now send your grandma this, and instead of meow, I can write, please email your credit card number to. But that doesn't seem to be working. Actually, I think that code might have been run. Yeah, so that code was run before it hit the server down here.
Yeah, it's like of the thing that I'm showing.
Yeah.
Like that's where it's getting injected.
Right here.
Yeah.
So you can see that it's building a link for me, and that's where it got injected. But if you noticed, when I tried to do it actually in the URL, it got sanitized and cleaned. Nope, it didn't. Oh, actually, no, it happened again. It happened again in the same place.
Yeah, because
That's crazy.
I mean,
No,
it's
it's pretty funny. Everybody here cares enough to think it's real funny. Yeah.
So another security naysayer type question here. We've been given simple examples of things like, give me back this form. That's a function that you have. I'm thinking about things that the server would normally do, maybe in a RESTful aspect where you have more frameworky things like authentication, authorization, maybe a more privileged function, something like a credit card transfer. Have you thought about the implications of that?
I haven't figured out a way that would even be remotely secure for my application to do that. I do have a way to, if you saw the form data response object, so if we make a form here, stop. We'll make a quick form, word called meow, and the what is done with the result. what is done with the result of the form is nothing, absolutely nothing. And then I type something in here. What's on the stack is a form data object. So something was posted, and it's now hidden from me until I start to extract information. So there is a way to post stuff, but yeah, I haven't thought of a good way to post sensitive information. Yeah, to be authenticated would be a good first step. But
We got time for one more.
yeah.
Would it be enough to use HTTPS? Because then, of course, the URL wouldn't be vulnerable to packet inspection, so you couldn't see the URL, or like generate a hash of any sensitive information, salt it, and send that back to the server before any sensitive data is passed in the clear over the network?
Yeah, so as Mr. Perez said last time, your security is only as good as your weakest link. That would solve a huge number of problems as far as all the problems that HTTPS and encrypting the sent information solves, which is nobody could get into it, theoretically, on the outside. But there are still a number of security issues present. Like, for example, sending me a form that does something evil. Or maybe I write a service that is a facade to this beautiful secure service, and I send you a URL language link to that instead. And so you think you're running it on the amazing golden service, but you're really running it on the prince who really needs some money. Yeah. Yeah, exactly. Yeah, you can build a phishing site in here very simply, yeah. Teach a man to fish, right?
All right. Thank you, Reed. Everybody get over Reed.
Thanks, guys.
Great discussion. All right, we'll see you next week, maybe. Somebody come volunteer. Love to hear you.